If I told you that a massive single-aisle aircraft would completely rewrite the international commercial aviation sector, what would you say? On June 15, 2022, the Airbus A321 XLR quietly made its first flight. However, this was done in a very different way from previous first-flight experiences. It flew over Europe for approximately 3.5 hours without fanfare. To observers, it might have looked like a regular A321 aircraft. However, no one realized that this was the beginning of a revolution. Like its other jumbo siblings, it could fly to distant destinations. But there was one difference. Its operating costs were much lower than those of its competitors. Why did the Airbus A321 XLR aircraft excite the commercial aviation sector? And what made this aircraft one of the most important commercial aircraft? Have you ever thought about these questions? To answer these questions, let's take a brief look at the history of the aviation sector. In the early days, when jet-powered passenger aircraft first began to blanket the skies, there was no need for such large aircraft to cross oceans. At that time, aircraft like the DC-8 and Boeing 707, which had single-aisle designs, could easily fly over large oceans. These small and weak aircraft were surprisingly capable of flying long distances considering their size. After these aircraft, the commercial aviation industry began to experience its golden age. In the 1970s, the golden age of jumbo jets such as the wide-body DC-10, Boeing 747, and L-1011 began. These massive aircraft had two aisles. They had spacious cabins and huge cargo compartments that could carry tons of cargo. Moreover, there were no three-jet aircraft until then. Airbus entered the aviation industry in 1974 with its first commercial aircraft, the A300. The company's strategic move in 1984 would change everything. That year, Airbus made a move to rival Boeing's 737 model with its A320 model. At first glance, this narrow-bodied model appeared to have a single aisle, but it laid the foundation for the most successful aircraft in commercial aviation history. Have you ever wondered why fuel and operating costs are so important in the commercial aviation industry? The answer is simple. Fuel accounts for approximately 32% of operating costs for jets. When efficiency is calculated, even the decimal places after the comma can save millions of dollars, leading to higher profit margins. As oil prices continued to rise and environmental factors became more significant, Airbus announced the design of the A320neo. In the aviation industry, neo means new engine. These new engines were not just slightly better, but revolutionary. The CFM LEAP 1A, Whitney PW1000G, and new Pratt engines had managed to reduce fuel consumption by around 20%. They also had other advantages, such as lower emissions and less noise. Every aircraft produced with NEO engines provided fuel savings compared to previous models, thereby ensuring economic superiority. Years later, in 2018, a significant development took place. Airbus introduced the A321 LR model. This modified model, designed with the NEO engine, featured 3 additional fuel tanks under the passenger cabin, enabling it to achieve an impressive range of 4,000 nautical miles. The A321 XLR model also obtained ETOPS 180 certification, successfully enabling long-range flights. ETOPS 180 allows an aircraft to continue flying for up to 3 hours from the nearest airport, even if one of its engines completely stops. Until then, transoceanic flights were dominated by large-body aircraft. However, the LR model took this capability away and succeeded in flying across the Atlantic Ocean. However, airlines wanted more. Have you ever wondered how far an aircraft manufacturer can push the boundaries? The result of pushing the boundaries is the A321 LR model. The XLR model was first unveiled at the Paris Air Show. It aimed to achieve something that had never been done before, a flight range of 4,700 nautical miles. Imagine flying from Delhi to London, or from the Maldives to Perth. What engineering technology could make all of this possible? In the LR variant, the removable fuel tank was permanently mounted next to the wing box. In the XLR model, the difference with this tank is that it replaces 4 standard acts. It weighs the same as one of them and takes up only half the space. The result of all this is revolutionary. Increased payload capacity, greater cargo capacity, and extended range are among its revolutionary features. However, this raises a critical question. If these single-aisle aircraft can fly advantageously thanks to all these features, what will happen to other wide-body aircraft? Do you think the A321 LR is only appealing to low-cost airlines looking to operate long-haul flights? You're mistaken. Many airlines with diverse business models have been impressed by the A321's low costs and have placed over 600 orders. This once again highlights the value of the A321 XLR design. Imagine you are managing Aer Lingus. It should be perfect. Flights from New York to Dublin see high demand in the summer and decrease in the winter. In such a scenario, if your fleet includes the A321 XLR model, you can use this aircraft at low cost during off-peak seasons. This allows you to manage the seasonal decline in demand without incurring losses. JetBlue takes a different approach. It prefers to reduce the number of seats on its A321LR aircraft to offer more premium comfort. The company has configured its aircraft to have a capacity of 138 seats. Compared to wide-body aircraft, this allows it to operate flights at a lower cost while offering premium comfort and higher passenger fares. All of these factors have contributed to the excitement surrounding the XLR. However, the designed aircraft also have some drawbacks or features that may require careful consideration. Airlines using the A321LR have had to make some choices. Should they prioritize longer-range flights with higher fuel consumption? Or should they opt for shorter-range flights with greater cargo capacity? For airlines, choosing one of these options has been a very difficult decision. However, many airlines have reduced the number of seats and focused on premium passengers. This means earning more money from passengers. Carrying fewer passengers in premium class means less baggage and more cargo. However, this was not a solution either, because companies were constantly forced to make calculations. How many passengers? How much cargo? How much baggage? How much fuel? Each of these criteria operationally affected other factors. These calculations might have worked for flights between Lisbon and New York. However, in longer distances like Europe, these restrictions had a significant impact. When factors like wind were added to the mix, aviation engineers had to choose between reducing the number of passengers or making stops for refueling. Years later, after the pandemic began, oil prices and cargo fees began to rise, changing the situation. Transporting cargo on passenger planes became an excellent source of income. Some jumbo jets managed to make a significant profit, even with empty passenger seats, thanks to the cargo they carried. During that period, cargo rates increased by €5 per kilogram, which was 3.5 times higher than before the pandemic. Previously, airlines viewed cargo transportation as an additional source of income, but they realized it accounted for 35% of their total revenue. This situation once again highlighted the inadequacy of small but long-range aircraft. This raises the question: if they choose to fly longer flights with more fuel and give up cargo capacity, will they lose out to the competition? The XLR's mid-fuel tank changed all the rules of the game. Airbus Aviation engineers permanently installed fuel tanks instead of removable ones. This allowed for longer-range flights without reducing cargo space. Commercial aviation companies no longer had to choose between cargo and long-range flights. They revolutionized the industry by optimizing both factors. The XLR offered airlines the Boeing 757, which was highly valued for its excellent range and high efficiency. However, there was a significant difference: modern technology and a 30% fuel savings. Despite production ending in the early 2000s, the Boeing 757 continued to serve the aviation industry because there was no other aircraft to replace it. However, there was a major issue with the XLR. According to the European Aviation Safety Agency, the XLR's fuel tank design raised safety concerns. In the event of a problem during landing, the section containing the fuel tank would be the first to absorb the impact energy. Could passengers survive in the event of a problem during landing or takeoff? The agency demanded more than theoretical calculations. In a worst-case scenario, what risks would passengers face with this fuel system? They requested that this be tested in a laboratory environment. As a result, Airbus engineers decided to redesign the base sections. In the new design, the lower fuselage section was redesigned using stronger and lighter materials. According to this design, the first impact force would be managed by the lower fuselage section. This section would absorb all the energy, preventing damage to the fuel tank. Designing this requires complex calculations regarding collision energy. This delay is causing the project to be delayed, which is causing tension for Airbus. Every new design must prove itself under non-standard conditions. Airbus maintains that its promises for this new design are still valid. The only downside is that the first flight will be delayed. Some aviation researchers predict that the implementation and certification of this will take about a year. This is not a short period of time, but it is considered relatively normal when compared to other aircraft design projects. Have you noticed that there are almost no revolutionary aircraft designs in the commercial aviation sector today? Airbus and Boeing have made their new designs possible through evolutionary changes rather than revolutionary ones in the initial stages. This has allowed XLRs to rewrite the entire scenario. For example, Iberia has started using XLR aircraft immediately to keep pace with the industry. Spanish airlines have begun using this aircraft on routes such as Boston to Madrid and Washington, D.C. in the U.S. The results for the companies are outstanding. A perfectly quiet cabin, superior performance, and fuel efficiency leading to reduced costs. Looking ahead, Aer Lingus has begun planning to use the A321 XLR for long-haul flights. LATAM is planning flights between Southern Europe and Brazil, bypassing traditional routes. JetBlue is continuing its plans for long-haul flights that cannot be operated by wide-body aircraft. These are just a few of the many plans in the pipeline. American Airlines will launch its first XLR fleet by the end of 2025. These aircraft will offer premium flight services with fewer passenger seats. India's airline Indigo is also expecting its first delivery soon. The company plans to serve destinations it does not currently fly to with its new aircraft. Aer Lingus, Jetstar, and Qantas are also accelerating their plans for their fleets. Despite the lengthy planning process, the industry is rapidly embracing the program. What would you think if you could fly non-stop between cities that are not connected? Listen carefully and just imagine flying directly from Frankfurt to Chennai and Nairobi. What were once uneconomical routes requiring large-body aircraft can now be flown with XLR. XLR is completely disrupting airlines' plans. Would you like to experience previously unexplored routes with XLR without the high costs of large-body aircraft with 2 aisles? This is exactly what XLR offers you. From an environmental perspective, it consumes 25% less fuel, causing less harm. This also helps reduce carbon footprint pressure among world governments. This is a very important issue in the commercial aviation sector. United Airlines has recognized these advantages and is planning new flights between Brazil and the U.S. It also aims to enter locations such as Europe, where companies such as Emirates cannot operate their large aircraft. The future of the A321 XLR looks very bright. Airlines are closely monitoring the performance of the XLR. Airbus is continuing its in-depth work on factors such as cabin improvements and aerodynamic developments for this aircraft. Aviation experts are making some claims about different versions of this aircraft. While some experts are proposing a larger A322, others are suggesting a Neo Plus with a longer range. The most notable of these claims is that it will be called the A321 XL and will compete with wide-body aircraft by adding more seats. There are even rumors that the XLR will be applied to the A320 in the commercial aviation sector. We will also address this topic in our new videos. Don't forget to follow us. Amidst all these developments, Boeing's silence is drawing attention. The 737 MAX family of aircraft, with its current design, does not have the space to accommodate additional fuel tanks. Although the 737 MAX has become competitive in terms of seat capacity, it lags behind in long-haul flights. Although Boeing's NMA project is expected to replace the 7577, it is still in the development phase. This gives Airbus an average of 7 more years. This is a very long time in the commercial aviation sector. This time frame provides sufficient branding opportunities for the XLR. However, the XLR's importance remains intact. A single-aisle aircraft promises ranges that a wide-body, twin-aisle aircraft could never achieve. Moreover, achieving this with fuel efficiency makes it seem indispensable. A small premium passenger load, twin engines, and a range of approximately 4,700 nautical miles are just a few of the reasons why it is significant. For passengers, the situation is a bit different. While this aircraft plans to reach destinations previously inaccessible by any other plane, its narrow cabin space could lead to a slightly stressful flight. Airlines may have to rethink passenger comfort in economy class. With a 3-3-seat configuration on long-haul flights, passengers in the middle and window seats are likely to frequently disturb those in the aisle seats. Premium cabins may also face different challenges. While airlines like Aer Lingus and JetBlue argue that premium travel is possible in single-aisle aircraft, design limitations due to restricted interior space are evident. Will premium passengers paying approximately $4,000 for a flight accept these aircraft, which cannot fully replicate the experience of larger-bodied planes? This will be determined by the passengers who shape the market. The A321 XLR is not an ordinary aircraft. It will be the protagonist of a new era that connects previously inaccessible destinations around the world. Could narrow but economical aircraft like the XLR replace large-body aircraft? Let's discuss this topic in the comments. Is the hub-and-spoke model coming to an end? Aircraft with this model have dominated the industry for decades by picking up passengers from large airports and distributing them to smaller ones. The XLR's low fuel economy will rapidly change connection points around the world. Have you ever considered the impact of all this on airport companies? Not all airlines around the world have the infrastructure for large-body aircraft. However, even with small investments, infrastructure issues can be resolved for these two-aisle XLR aircraft. The future of the aviation industry is taking shape before our eyes. We couldn't even imagine this a decade ago. The challenges faced during the pandemic have significantly accelerated the development of the commercial aviation sector. The development of these single-aisle, long-range aircraft actually began years ago. What you are hearing now is not a temporary arrangement, but a redesign of how the aviation market connects the world. Did you like our video examining this revolutionary new design in commercial aviation? Subscribe and join us in the comments. Whatever you do, may God be with you.